Hello, welcome to the series for complex numbers and quadratic equations. This series will be helpful for anyone studying in 11th standard and for anyone who wants to learn about complex numbers from scratch. In this series, we will be covering the syllabus given in the 11th NCERT book, which includes an introduction to complex numbers, algebra of complex numbers, modulus and conjugate, Argand plane and polar representation. It also has an exercise for quadratic equation, so we will be sure to cover that as well. And then in the end, we will do some miscellaneous questions. While covering all these topics, we will also be simultaneously covering or solving problems based on these concepts. And at the end of the series, we will be covering these miscellaneous questions. All the questions that are important from your exam point of view will be covered comprehensively in the series. And all of these videos are also going to have questions attached with them. So do try them as well. Now, let's get started with our topic. Numbers. So we've been learning about numbers since we were kids, right? Even before we came to school, we already knew how to count at least from 1 to 10. And when we joined school, we were told that all the numbers that we have been learning, say 1, 2, 3, till whatever number we can think of, are called as natural numbers. But then they realized that, oh, we forgot to add a zero. So they told us that all the number from 0 till 1, 2, 3 till whatever number you can count are called whole numbers. But then we learned that there also exists number on the other side of the number line as well. That is, we have numbers not from 0 to infinity, but minus infinity to infinity, and we call these numbers as integers. And after learning about all these numbers, we studied fractions, right? 1 by 2, 2 by 3. And now what are we going to call these numbers? So we gave a new term, rational numbers. So we called all of these numbers as rational numbers. But then we also have irrational numbers, right? So we have to include those as well. So all of these numbers together, we call them real numbers. And in real numbers, we have everything. We have our negative numbers, we have our 0, we have our pi, we have our 2 by 3, any number that you could ever think of. We had we have here under real numbers. So what was left? Then came a new concept, variables, right? Now English has a new use for us. We learned our PQR, ABC, XYZ, whatever form of triplets you could think were variables. And using variables, we made equations. First, we made linear equations, and then we made our very favorite quadratic equations. And you must have studied and solved your quadratic equations in your 10th standard. So they look like this. So just to refresh your memory, I'll ask you to solve me a simple quadratic equation. Say x squared minus 1 is equal to 0. So what do you think is the answer? I'll give you a few seconds. Okay, let's try it. So x squared is equal to 1. X is equal to plus minus under root 1. So that means x is plus minus 1. So you will say that So you would say that the solution for the equation is plus minus 1, or you will say the roots for x are plus minus 1. That's great. That means we remember something. Now I'll give you one more equation. X squared plus 1 is equal to 0. Okay, let's try to solve this. So x squared is equal to minus 1. Okay, so x is equal to plus minus under root minus 1. But wait a second. Even before coming to this step, right at this step, let me remind you something. While solving quadratic equations, you must remember the formula b, which was b square minus 4ac, and we knew that b square minus 4ac is always greater than or equal to 0 for us to have real roots or or a real solution. But here in this equation, x square is equal to minus 1. That means if we calculate our d, it is coming to be less than 0, which is not possible because then we will not have any real solutions. So what is the solution to this problem? What do you think? So all the mathematicians came together, not literally, but over time, and devised a new term. So they said that okay, let's solve this problem. X squared plus 1 is equal to 0. X squared is equal to minus 1. X is equal to plus minus under root minus 1. So all the mathematicians came together, not literally at one place, but over time, and called this minus 1 under root an iota. So which basically is an imaginary number. So the mathematicians created an imaginary number and called it an iota, which can be denoted by a small I or a capital I. Now this gives us the solution for our equation as x is equal to plus minus iota. So now this is not the only equation that you may have come across while solving quadratic equations prior to this session, which had no real roots, and your answer would simply have been that no solutions are available for the equation. But now all of those equations have solutions. Say you had come across equation x squared plus 9 is equal to 0. So now this x is equal to plus minus 3 iota. But if it were x squared plus 16 is equal to 0, then we have x is equal to plus minus 4 iota, and so on. So this basically opened a Pandora's box for mathematicians. And now we can solve a lot of new equations and we'll have more answers than that were available before. So now using this imaginary number that we have, which is iota, we devised a new number and called it a complex number. So now to define the complex number for you. So any number that has a real part and an imaginary part can be defined as a complex number. Now you're going to ask how so? So look at this. So let's say we have a number and we are calling it number z. So it is a plus iota b. So here we have a and b as real numbers where a is our real part of the equation, real part of the number as talked here, real part, and our iota b is our imaginary part as talked in the definition, imaginary part. So basically the combination of real and imaginary parts is our complex number, which can be written like this. And to give it a better definition, we will write it like this. Zn is equal to an plus iota bn, where n can be any number from 0 to infinity. So we can have z1, a1 plus iota b1, z2, a2 plus iota b2, and so on and so forth. So as we discussed before, that this opened a Pandora's box for us, and now we can solve and know about many more things that we could have done, that we could not have done in the past. So this also must tell you that complex numbers are a very important topic, and we are going to study them as a basis in your class 11 syllabus, but they are going to come up in your class 11 later on and in your plus 2 syllabus as well. You're going to be having complex numbers in your algebra, in your trigonometry, in your geometry. They are going to be a very important part of all of these chapters. So make sure you understand this topic very thoroughly and there are no doubts left in your mind. So this marks the end of this video lesson, and you may see me in the next video where we will be covering the next topic as given in your NCERT, that is the algebra of complex numbers. Thank you.